Okay, 13, the least squares problem. So this is, like it says here, same idea that if you had me or 151 with another instructor in our program, whenever we were unable to integrate a function last year, we would approximate. We had several approximation methods available to us to use. So that's essentially what we're talking about here. So if there's no solution, can we find an x as close as possible, right? Estimate something. Let's see if we can get close. So that's called the least squares solution. Again, it's denoted x hat, same x hat as from the previous section there. And it's such that b minus ax hat is less than or equal to b minus ax for all other x's. In other words, it's the closest one. So if you want to think about this in the 2D plane, right? So if we're going to talk about the 2D plane here, and we have some other vector here, the closest is going to be that, basically that projection. So that's what we're looking for, the projections. And the set of least squares solutions coincides with the set of non-empty solutions to the normal equations. A transpose AX is equal to A transpose B. Again, if A transpose A is invertible, that implies the columns of A are linearly independent and vice versa. If the columns of A are linearly independent, then A transpose A is invertible. So AX equal B has only one least squares solution, and that's it. And that's basically coming out of this piece right here, right? If you take the inverse of that and left multiply both sides by it, you're going to get this result here. So that's how you find x hat. Okay, so let's find the least squares solution to an inconsistent system. So if you try to solve this, you get no solution. We understand that. We're trying to find the least squares solution, right? The best approximation. So we calculate A transpose A. It is invertible, right? Because the determinant is non-zero. So we find the inverse of A transpose A, which is what's here. And then A transpose times B gives us this. And so we multiply this out, and that's our least square solution. Okay, again, that's not a solution, but it's the closest one we have. So you'll go ahead and do the same thing here with this worksheet. Again, find A transpose A, then make sure it's invertible. It is. Find its inverse, and then use that same technique that we just used before. Similar here, right? Find a least square solution by constructing those normal equations and then solving for it.